In the final lecture of this section, we will get familiar with Apple's WidgetKit framework. Using this WidgetKit framework and API, we can easily build widgets in SwiftUI and make them available across iOS, iPadOS, and macOS. As you may know, widgets come in multiple sizes, and users can visit the new Widget Gallery to search, preview sizes, and place them anywhere on the home screen to access important details at a glance. Adding a widget to our app requires minimal setup, and a few decisions about the user interface's configuration and style. What you also should know about widgets, that they display their content using SwiftUI views. In this tutorial, we will focus on how to create a static widget extension in SwiftUI. Alright, without further ado, let's launch Xcode and start coding along with me. Widget extension. First of all, we start by learning how to add a new widget target to our existing application. To do that, let's open the Devote project in Xcode and choose File, New, Target from the main toolbar menu. We need to search for the widget extension using the iOS application extensions search field, as I show you. Now please, select Widget Extension, and then click Next. Then we need to enter the name of our extension. Give it the following name, Devote Widget. Since our static widget won't provide user configurable properties, therefore uncheck the Include Configuration Intent checkbox as I do. Excellent job so far. After all these settings, click Finish. Shortly after we created a new widget extension, a new pop-up window asks us whether we want to activate the new scheme. Of course, we will click Activate, and we're good to go. Widget Template. The widget extension template provides a starting point for creating our widget. You can find this widget in a separate group folder in the Project Navigator. Please select the Devote Widget folder, and unfold it to see all files in it. As you can see, there is an info property list file, then an assets catalog, and a Swift file. Let's select the Devote Widget as Swift file, and look at the default template structure. There is a bunch of code in this file, but don't be scared. We will discuss all of them, but before that, I will show you how we can build and run a widget extension in Xcode. Testing widgets. Go to the top toolbar and click on the scheme as I show you. As you can notice, we now have two schemes, two targets, one for the Devote application, and a new one for this widget. And when we opened this widget Swift file, then this new scheme became the active target. That's why when we click the Build and Run, then Xcode starts compiling the widget for us so we can test it in the simulator or on an actual device, depending on what we have chosen. As you can see, a new widget was added to the home screen automatically with the current time. It's worth mentioning that in a real scenario, no widgets will be added automatically when a user installs an application from the App Store. Users can add a new widget to the home screen by editing it. One way to do that is to tap and hold our finger on any app icon or widget. This will trigger a new context menu, and after selecting the Edit home screen, we can see a new plus button on the top left corner. Now let's tap on this Add button. As you can see, a new sheet showed up with a search field, and the list of all available widgets. This is the new Widget Gallery. By default, all widget inherits an icon from its parent application. Please select the Devote widget to choose a widget size. A widget could potentially have 3 different sizes. To check them out, we need to swipe to the right and left. There are small, medium, and large size widgets provided by this template. Alright, after learning how to build, then run and test the widget template, we can jump back to Xcode and take a quick look what's going on under the hood. Basics. Since the new WidgetKit framework and its SwiftUI API is a huge topic itself, therefore it's impossible to teach everything about it in this short lecture. That's why we need to take baby steps to get familiar with it. My main goal with this class is to build together a static widget. However, before doing that, it's worth knowing the basics of how a widget works. Having said that, let's get started. So, what widgets are in a nutshell? With widgets, users get timely information from their favorite apps at a glance. Also, users can use widgets on home screen to keep some content or helpful information at their fingertips. But not only that, users can use widgets from Today view by swiping right from the home screen or lock screen. As for widget developers, we need to get familiar with three fundamental building blocks and how they work. These are the widget families, entries, and timelines. Widget family. When we say widget family, then we think about different widget sizes, such as small widgets, medium widgets, and large widgets. The second important thing. Timeline. The second important thing is the timeline. The way widgets provide information is through something called a timeline object. To tell WidgetKit when to update a widget's view, a timeline provider generates a timeline. A timeline contains an array of timeline entry objects and a refresh policy. With this, each timeline can manage how to update a particular widget, which is the actual data coming from the main application that the widget can use. Entry. An entry creates a timeline for when we want WidgetKit to update a widget's view. To create timeline entries, we need to declare a custom type that conforms to timeline entry. Each entry specifies the date we would like WidgetKit to update the widget's view and any additional information that our widget needs to render the view. Reload policy. The timeline's refresh policy specifies the earliest date for WidgetKit to request a new timeline from the provider. What's worth knowing about the reload policy is there are three types. The default refresh policy, at end, tells WidgetKit to request a new timeline after the last date in the array of timeline entries we provide. This means when the end of the timeline is reached, then the widget will start over with a new series of entries. It will keep updating the widget for undefined times. The second type is the so-called after date. We should use the after date to indicate a different date, either earlier or later than the default date. Specify an earlier date if you know there's a point in time before the end of your timeline entries that may alter the timeline. Conversely, specify a later date if you know that after the last date, your timeline won't change for a while. And finally, never is the third reload policy type. Alternatively, we can use the never policy to tell WidgetKit not to request a new timeline at all. In that case, our app has to use Widget Center to prompt WidgetKit to request a new timeline. When we decide to use this policy, our responsibility is to determine when updates will be executed. Limitations. Just keep in mind that widgets are not mini-apps, and they have limited capabilities. And this is designed on purpose so widgets couldn't overuse or abuse the device's energy, memory, and other crucial resources. Also, note that the widget's view might not be updated precisely at a timeline entry's data and time. That's why the update might occur later. Widget Template. Now that we can understand the basics of widgets, then we can jump back to Xcode and walk through all code of the default widget files. First things first. As you can see, we have to import the WidgetKit framework. It's as simple as that. Second, we have a provider struct that conforms to the timeline provider. A timeline provider advises WidgetKit when to update a widget's display. There are three required functions in the protocol. Inside this timeline provider, a widget placeholder function provides a timeline entry representing a placeholder version of the widget. After that, there is a getSnapshot function that provides a timeline entry that represents the current time and state of a widget. And finally, there is a getTimeline function that provides an array of timeline entries for the current time, and optionally, any future times to update a widget. Pay attention to the code inside this function. First, there is a current date property. The second part generates a timeline consisting of 5 entries an hour apart, starting from the current date. Not particularly a useful widget, in my opinion, but hey, That is what we got so that we can use it as a starter point. Next, there is a simple entry struct with only one property, a date, so that WidgetKit can render a widget with it. The next section. Here is something essential to know. As you know by now, we can only create a widget with SwiftUI. Since WidgetKit is a brand new framework, Apple decided to leave behind the old technologies, aka UIKit, in favor of SwiftUI. This devote widget entry view is where we create the actual layout and design for the widget. As you can notice, there is a body part similar to our main app. So far, there is nothing fancy there, only a text view. But at the end of this lecture, this code will be dramatically changed. Next section. Don't be confused about the order of these sections. It will be pretty logical at the end. This block is the most crucial part of widget creation. As you can see, we develop a widget by creating a struct that conforms to the widget protocol. With the main attribute, we declared that this struct will be the entry point of this widget. So the app will take care of creating all the needed things to start this widget when the time comes. The only requirement of the widget protocol is to provide a body property that should return an instance of widget configuration. SwiftUI provides us two structs that conform to widget configuration, a static configuration, and an intent configuration. We can use intent configuration to provide user configurable options for our widget. A great example of that is Apple's weather widget, in where we can select the current weather conditions and forecast for a location. In this lecture, we're using static configuration. The static widget configuration allows us to register a widget configured by the developer that from time to time updates its data. Also, the static configuration needs 3 parameters. Let's take a look at them one by one. Kind is a string that identifies the type of widget. Your app might have multiple widgets. The provider conforms to the timeline provider protocol and is used by the system to fetch widget data. Finally, we need a view builder closure that describes the SwiftUI view for displaying widget data. With all these settings, the system will try to predict the best time to perform widget updates using providers. But we can always ask to update widgets using Widget Center. We will learn how to develop more advanced widgets later on in this masterclass. Now let's move on to the last code blocks in this file, and start doing something worthwhile. Widget previews. Please scroll down to the previews section. As I mentioned before, widgets usually come in 3 different sizes: small, medium, and large. In my opinion, it's worth knowing how we can test these different widgets properly on the canvas. First of all, select the whole devote widget entry view with its modifier as I show you. After that, Command+, click on this view's name. From the context menu, please select the embed into a new group option as I show you. Great! Inside this new group, we need to paste the code snippet 2 more times, so at the end, we will have 3 widgets altogether. Last but not least, let's modify the widget family for the second and third widgets, shall we? Enter. Family, system medium. Then enter. Family, system large. And there it goes. With this modification in the preview section, we can visually test all widgets from the smallest to the largest ones. How cool is that? Widget assets. Regular iOS projects share many similarities with widgets. For example, both of them have a dedicated asset catalog. Please select the Assets group in the Project Navigator as I do. As you can see, a widget could have its own accent color, app icon, and what's new here, a dedicated widget background. We will continue by adding icons for this widget. First, select the app icon in the middle pane. Now Ctrl+click on its name. This will pop up a new context menu. Choose the Show in Finder option from this menu. After that, open the app icon folder. There are no icons. Now we need to open a new Finder tab or window, as I show you. After that, please navigate to the Resources folder. In this folder, we can find a widget folder as well. Open this folder. There is a widget icon inside it. Now open the app icon group and select all files inside this folder and copy them to the clipboard as I do. Finally, switch to the empty app icon folder in the previous Finder tab and paste all files from the clipboard into this group. As you can notice, shortly after this, our new widget got dedicated icons that could be different from the inherited iOS apps icons if we wish to differentiate them for some reason. Next, go back to the Widgets Resources folder and select the rocket image. After that, drag and drop it into the asset catalog as I show you. Super! To sum up what we did so far, we added a graphic file and dedicated icons for the widget. Now, let's do something new. Please select the widget background asset from the middle pane. As you can see, this is a special color set with no default value. Now select this empty color slot in the editor as I show you. After that, we make sure that the inspector's pane is open, so let's do it. Activate the Attributes Inspector, which is the fourth menu. In this Attribute Inspector, we can add any new color that will be used in the widget editor. More specifically, it will be the background color of the Add Widget button. Click the Contents None option and choose the sRGB color spec from the drop-down menu as I do. Here we need to change the input method from floating point to 8-bit hexadecimal. After that, enter the following color value. #D13A8. This value will generate a nice pink color for the button's background. Shared assets. So far, we practiced how to add dedicated assets for a widget. However, there is another way to do it by sharing an existing asset of the main iOS application. And this is what we're going to do right now. First, open the Assets catalog in the Devote iOS app group. Now, please select the logo file from the middle pane as I show you. After that, go to the Inspector's pane on the right hand and select the File Inspector from the menu bar as I do. In this File Inspector, we can see a new Target Membership section. As you can see, this logo file is active only for the iOS application. It means that only the iOS app can use it and nothing else. Our goal is to make this logo file available for use for our widget as well. To make it happen, we need to check the checkbox option and modify the target settings. It couldn't be easier, am I right? From now, we can use this logo file in our widget target. I hope that you learned something new by doing this exercise. Widget creation. In the rest of this lecture, we will create a static widget that will adapt to all sizes across the board. But before doing that, I would like to highlight two settings that we can further modify. We can notice two new modifiers in the main Devote widget, namely the configuration display name and the description. Let's change the default values a little bit, shall we? For the name, enter this text: Devote Launcher. And for the description, this one. This is an example widget for the Personal Task Manager app. You will see how this information will be shown in the widget editor later on. Next. First of all, navigate the cursor to the body section of the Devote Widget Entry view. Then comment out the text view with the time. We will replace it with our custom design and content. Nice! Now, let's start developing the new design. Enter the following code. Z stack. New comment, the end of the Z stack. Then enter this code. Background gradient. Oops! Something went wrong. We got a new error message that the compiler couldn't find the background gradient in our widget target. This happens when we forget to share a specific file with the new target. To fix this error, first, we need to open the constant Swift file. Then in the File Inspector pane, we have to add the widget as a new member of the target membership. So let's do it right now. It's done. We can jump back to the Devote widget and continue our work. See, the error message has gone, and there is a new linear background in each widget on the canvas. Next, on top of this background, we're going to put two images and a text view. Let's start with the rocket image, shall we? Enter the following code. Image. Rocket. Dash, small. Resizable. Scale to fit. As you can notice in the preview, the image has been scaled up or down, depending on the particular widget size. We can continue by adding the logo to the top right corner. Enter. Image. Logo. Resizable. Frame. Width. 36. Height. 36. Now we need to move this logo to the top right corner. And one of the possible solutions to do that is using SwiftUI's geometry reader. First, Command+click on the Z stack. Then select the Embed option from the context menu as I do. After that, we need to replace the placeholder container with the geometry reader. Geometry reader. Geometry. In. New comment. The end of the geometry reader. So far, so good. With the geometry reader, we can precisely position the logo image wherever we want. To do that, let's add the following modifiers to the logo. Enter. Offset. X. Geometry.size.width. Divided by 2. -20. Y. Geometry.size.height. Divided by -2. +20. This code will position the logo to the top right corner of the widget. Now let's add some padding to it as well. Enter. Padding. Top. 12. Padding. Trailing. 12. It's much better now. Next, let's create a new text view after the logo. Enter the following code. Text. Just do it. Foreground color. White. Font. System. Footnote. Design. Rounded. Font weight. Bold. Padding. Horizontal. 12. Padding. Vertical. 4. Background. Color. Red. 0. Green. 0. Blue. 0. Opacity. 0.5. Blend mode. Overlay. Clip shape. Capsule. We're almost done. Now, please embed this text view into a new horizontal stack container as I show you. Hstack. New comment, the end of the horizontal stack. Nice. For now it does nothing, but later on, we will use it for further positioning. After all this, we need to add some new modifiers to this hstack. Enter. Padding. Then, offset. Y. Geometry.size.height. Divided by 2. -24. This offset will ensure that the text view is always positioned at the bottom part of the widget. We could call it a day because the general design of our widget is completed. The layout and the look are identical in each widget, as you can see in the preview. However, we can make it much better if we could differentiate them from each other somehow. That's why I would like to show you how to make the design adaptive depending on the widget family. It sounds great, isn't it? So without further ado, let's do it. Widget Family. First, we're going to create a special property that we can use in different conditions. Navigate to the top of the Widget Entry view and enter Environment \widget family variable Widget Family. As you can see, with this environment property wrapper and the widget family key, we can get the actual size of any widget instance. Also, we can always use this widget family environment value to understand the current widget configuration size and present different views. To prove it for you, scroll down to the H stack, and let's create a new conditional view after the text. Enter this code. If widget family not equal to system small, then add a new spacer to it. And there it goes. Do you see how we moved the text to the bottom left corner with this code in the medium and large widgets? How great is that? But we do much more using the widget family property. Jump to the logo view, and let's modify the frame modifier as I show you. Frame. Then, let's wrap the width and height attributes in new lines. Width. Widget family. Not equal to system small. Question mark. 56. 36. Height. Widget family. Not equal to system small. Question mark. 56. 36. Now we need to adjust the padding of the logo a little bit. First, select the code from the widget family to the question mark, and copy it to the clipboard. With that now, we can modify the padding. Second, paste the code from the clipboard before the value as I do. Third, enter 32. 12. And last but not least, do the same with the trailing as well. Paste the code from the clipboard, then enter 32. 12. As you can see, we can make any UI elements bigger or smaller depending on the widget family. Font varieties. We won't stop here, and I will show you another way how we can use this widget family. Alright. Scroll up a little bit so we can create a brand new computed property. Enter the following code. Variable. Font style. Font type. If widget family equals to system small, then return system. Footnote. Design. Rounded. Else. Return system. Headline. Design. Rounded. With this code, we can differentiate the size of the text. To see how we can do it, navigate to the text view and modify it. Font. Font style. There it goes. Can you notice these subtle differences in the previews? I hope so. This widget family environment property gives us the power to change and modify the layout and design of each widget conditionally as we wish. How cool is that? I hope that you can appreciate its benefit as much as I do. Final test. And that's all for today. We have nothing to do here. Let's build and run the completed Devote application either on an actual device or in the Xcode simulator. So let's do it. We start by editing the home screen, as I show you. Then we need to select the Devote widget from the Widget Gallery. In the widget editor, now we can select any static widget that we want to add to the home screen. By the way, do you see the custom widget name with its description? Not to forget about the pink button at the bottom. Our new widget extension conforms to the overall design system of this application. How amazing is that? Alright, after we choose a widget, then we enter an edit mode where we can move the widget to their preferred location. I'm quite speechless that you came along with me so far. Please, take my congratulations. You did a great job developing this fantastic mobile application. And I really mean that. What I would ask you is to stand up, leave your computer, and show your friends and family members this awesome app as soon as possible. But not only that, you can share your achievements on social media as well. Undoubtedly, you deserve recognition from others, and let the world see what you have just developed. You got the momentum, so don't stop now. I hope you will enjoy the upcoming section's cool projects, as you did so far in this masterclass. Just one more thing. I would appreciate it so much if you could take the time to give this course a 5-star rating. Or even better if you could share your learning experience with other students by writing a helpful review about this course. This way, you not only motivate me to publish more practical projects to this masterclass, but at the same time, you can help other students to be informed about this excellent learning material as well. Either way, I would be glad to read your success story too. Thank you so much.